In this video, I'm going to go over these homework problems from the logistics section. This is on page 287 and 288. And before I do that, I just want to remind you that the logistic function looks like this, where a times b to the x, that's a typical exponential function, but now it's added into a more complicated function. And later this week, you'll see that this has a lot to do with the spread of a virus that we're currently dealing with. So I'm going to do the evens, and you're going to do both the evens and the odds in this assignment, but I'm leaving the odds for you to do. They're going to be similar to what I model here, and you can check your odd answers in the back of the book, and I expect you to check your odd answers. And if you did something wrong, you should be coming for some extra help. So 42 is, and it says you can use your calculator, but you don't need to, and I'm going to show you that you don't need to. 1 plus 5 times 0.2 raised to the x. Okay, so the first question, it says find the y-intercept and the horizontal the horizontal asymptotes. So the y-intercept, we know that means f of 0. So we're going to plug 0 in. What's f of 0? 18 over 1 plus 5 times 0.2 raised to the 0. But this is, right, this is just 1. So this is 18 over 6. So that's 3. So the y-intercept is 0, 3. Now, we know that logistic functions look like this. So we're going to, they have this general shape. Okay, if they're going up, if they're going down, they have a different shape. They just go down the other way. And so this is going to intercept here at 0, 3. And now let's look at the end behavior. What are our asymptotes? And the asymptotes, horizontal asymptotes, are always end behavior. So limit as x approaches infinity of 18 over 1 plus 5 times 0.2 raised to the infinity. Now, what is 0.2 raised to the infinity? 0.2 times 0.2, which is the same as 1/5 times 1/5 times 1/5. Keep going. When b is less than 1, when you raise that base to the infinity power, that gets smaller and smaller and smaller. So this is going to 0. So we're getting 18 over 1 plus 5 raised to the 0. So the limit as x approaches infinity is equal to 18 over 1, which is 18. So I should have a horizontal asymptote up here at 18. So this is y equals 18 is one horizontal asymptote. Now the other horizontal asymptote occurs when the limit as x approaches negative infinity of 18 over 1 plus 5 times 0.2 raised to the negative infinity, right? So the limit as x approaches negative infinity of this function, I just put it in here, is going to equal 18 over 1 plus 5 times. Now, if I raise 0.2 to a negative, right, so 0.2 is 1/5. If I raise that to a negative, that means it's 5 over 1 to the positive infinity. 1/5 to the negative infinity. I can take that negative and flip the fraction and raise it to a positive infinity. So this is going to be 5 raised to the positive infinity. That's huge. That's infinity. So this becomes 18 over 1 plus infinity, which is 18 over infinity, and the limit is 0 when you do that. And so the other asymptote is y equals 0. And that's how you do this without your calculator. Okay, let's do 44. Number 44. F of x is equal to 9 over 1 plus 2 times e raised to the negative x. So I'm just going to rewrite that so that we can see that this could also be considered 1 plus 2 times 1 over e raised to the x, because e to the negative x is the same as 1 over e to the positive x. Okay, f of 0. If I plug 0 in, I get 9 over 1 plus 2 times 1 over e to the 0. Well, that's just 1, anything to the 0. So I get 9 over 1 plus 2, which is 9 over 3, which is 3. So the y-intercept is 0, 3. Now, end behavior. Limit as x approaches infinity of this function is going to be 9 over 1 plus 2 times 1 over e raised to the infinity. Well, 1 over e, that's the base. The base is less than 1. If I raise a base that's less than 1, because remember, this is like 1 over 2.7, 1 over 3. That's a decimal below 1. If I multiply that over and over and over again, as it goes to infinity, this gets smaller and smaller and smaller and smaller. And so this becomes 9 over 1 plus 2 times 0, which is 9. So I have a upper horizontal asymptote at y equals 9. And if I look at the lower horizontal asymptote, I'm going to do the same thing. Let me just erase that so I can put it below it. I'm going to do the same thing, but I'm going to use negative infinity. So the limit as x approaches negative infinity is going to be 9 over 1 plus 2 times 1 over e to the negative infinity, which, if I do that, the negative flips that e back up, so I get 9 over 1 plus 2 times e to the positive infinity. E to the positive infinity is 2.7 times 2.7 times 2.7 times 2.7. This is huge. So I get 9 over 1 plus something huge, which is 0. So I have the lower bound on this is y equals 0. So if I was to sketch this, I would have a y-intercept of 3, a lower bound of 0, an upper bound of 9. And I know based on which infinities, as x approaches positive infinity, I was going towards 9. As x approached negative infinity, I was going towards 0. So I can sketch that graph with just the information that I had. And I have a y-intercept there of 0, 3. Okay, I'll do the rest of the problems on a second video.